In this video, we will take a look at the calculation of the range and the interquartile range. The range and the interquartile range measure the dispersion of a set of data. In other words, they measure how widespread the set of data is. To calculate the range and the interquartile range, first of all, we should realize that there are two kinds of data. The first one is called the ungrouped data, and the second one is the grouped data. When we have a set of ungrouped data, it means that we exactly know each datum in this data set. For example, from this table we know that there is one datum 23, one datum 24, 3 data 25, 2 data 26, and 1 datum 27. We exactly know the value of each datum in this data set, and this is an example of the ungrouped data. On the other hand, for a set of grouped data, class intervals are given, and we do not know exactly what the data really are. For example, from this table, we know that there are two data ranging from 10 to 19, but we do not know exactly what these data are. Also, we know that there are 5 data ranging from 20 to 29, 8 data ranging from 30 to 39, 6 data ranging from 40 to 49, and 3 data ranging from 50 to 59. That means for a set of grouped data, we know the distribution of the data, but we do not know exactly the value of each datum in this dataset. For ungrouped data and grouped data, we have different ways to calculate the range and the interquartile range. Now let's take a look at the calculation of the range. The range is defined as the difference between the largest datum in the dataset and the smallest datum in the dataset. For ungrouped data, the calculation of the range is simple. From this table, we know that the largest datum is 27 and the smallest datum is 23, and therefore the range is just the difference between 27 and 23, which means the range is equal to 4. However, for grouped data, it would be quite impossible to locate the largest datum and the smallest datum because we do not exactly know the value of each datum in this dataset. Therefore, when we calculate the range of a set of grouped data, we use the upper class boundary of the last class interval to estimate the largest datum, and we use the lower class boundary of the first class interval to estimate the smallest datum. From this table, the upper class boundary of the last class interval is 59.5, and the lower class boundary of the first class interval is 9.5. Therefore, the range is equal to the difference between 59.5 and 9.5. Therefore, the range is equal to 50. Sometimes the grouped data may not be provided in the form of a table. Instead, they may be provided in the form of a cumulative frequency polygon or curve. When we need to calculate the range based on this given cumulative frequency curve, first of all, we should locate the upper class boundary of the last class interval. It is the value corresponding to the highest point of this cumulative frequency curve. That means the upper class boundary is $28,000. For the lower class boundary of the first class interval, it is the value corresponding to the lowest point of this curve. That means it is $4,000. Therefore, the range is equal to the difference between $28,000 and $4,000, which is equal to $24,000. And to calculate the range, make sure we have the unit. Range is a simple measure for dispersion, but it can be easily affected by extreme values in a dataset, and therefore we need to learn the concept of the interquartile range. To understand the calculation of the interquartile range, first of all we should understand the concept of quartiles. After arranging the data in ascending order, that means from smallest to the largest, the datum in the middle is called the median. In mathematics, we also call median the second quartile or Q2. And then the median of the first half of this data is called Q1 or first quartile, and the median of the second half of this data is called Q3 or the third quartile. What's more, we may call the smallest datum Q0 and the largest datum Q4. In this way, Q4 minus Q0 is known as the range that we have just learned. On the other hand, Q3 minus Q1 is known as the interquartile range in mathematics. Now let's take a look at how we should calculate the interquartile range for a set of ungrouped data. Let's take a look at these two examples and see how we should calculate the interquartile range of these sets of data. For part A, first of all we arrange the data from the smallest to the largest, And we know that there are 7 data in this data set, and the fourth one, which is 15, is the Q2 or the median. Now we should ignore this datum 15, and the first 3 data should be regarded as the lower half of this data, and the last 3 data should be regarded as the upper half of this data. Now the median of the lower half, which is 7, should be Q1, and then the median of the upper half, which is 24, should be Q3. Therefore, the interquartile range is equal to 24 minus 7, which is 17. For part B, again we first of all arrange the data from the smallest to the largest. We have 8 data in this data set. That means this is an even number, and we can directly separate this data set into 2 halves. The median of the lower half is known as Q1. Therefore, Q1 is equal to the average of 8 and 14, which is 11. The median of the upper half is known as Q3. Therefore, Q3 is the average of 35 and 37, which is 36. As a result, the interquartile range is equal to 36 minus 11, which is equal to 25. This is how we should calculate the interquartile range for a set of ungrouped data. For grouped data, this is a little bit special. We can only calculate the interquartile range when a cumulative frequency, polygon, or curve is given. From this cumulative frequency curve, in order to calculate the interquartile range, first of all we should locate the total frequency. And it is corresponding to the highest point of this curve, which is equal to 72. To find Q1, we should first of all multiply the total frequency by 1/4, which is equal to 18. And then we should look for 18 from the vertical axis, and then we read the corresponding monthly salary, which is $10,000, and therefore Q1 can be estimated as $10,000. Similarly, to find Q3, we should first of all multiply the total frequency 72 by 3/4, which is equal to 54, and then we look for 54 from the vertical axis, and then we read the corresponding monthly salary, which is $16,800. Therefore, Q3 should be estimated at $16,800. As a result, the interquartile range is equal to Q3 minus Q1, which is equal to $6,800. This diagram can summarize what we have learned in this video. For the range, it is equal to the difference between the largest datum and the smallest datum. For the interquartile range, it is equal to Q3 minus Q1, and Q2 is known as the median for a set of data.